Hello, this is Roger Brogan, and this is a video about the expressive type system in FSharp and comparing it a little bit to C#. So the setup here for this demo is just a regular Visual Studio solution. I've got a console app for C# here. You can see kind of the standard boilerplate. Also got a console app for FSharp with also its standard boilerplate. So the scenario we're going to go through here is just to see how expressive the F# type system is. And what I mean by that is, can we get something that maybe even communicates business rules and is a lot safer with F# versus what we get with um, C#. So the scenario we're going to go through is thinking about taking payments. And there's lots of things about dealing with payments. There's different kinds of payments. We can have checks. We could have cash, we could have credit cards, those are standard things, and then we could expand into like PayPal and Wemo and different other kinds of things that we could do. But let's just say for the sake of argument here, we want to start modeling the types for this. So let's say that the way that we have to model types in C# is by using classes. So let's say that we have a class here that represents our cash. And you're going to see some things. These aren't best practices for code layout or whatever. Obviously, I'm throwing them in the same file here. We would obviously lay this out a little bit differently, but this is just for the sake of the demo. And let's say that we have a class here for check. And we'll also kind of dispense with the fact that, using public members for these things is not really a good idea either. We need to have some validation around these. We shouldn't just be able to set a check number to any int. We shouldn't be able to do that, and we shouldn't be able to set the date that the check was written to any arbitrary date either, right? It should be, ideally from now or sometime when it was actually created and signed. Let's say that we're going to take a credit card. And let's say that we're also going to do for a string for the card type. And, we're going to need card number. And it will also have a expiration date, which is important. And it may have additional information about this. And at this point, we could say, okay, these are going to be payment methods, and I could say, okay, I want an interface here, a kind of standard payment method, and to establish a relationship between these, we would need all of these to implement this interface. And then we could do something like this down here. We could say, okay, we now have finally our payment class. And it's going to have an amount, which needs to be in a decimal here. And let's say we're international, so we need a currency. And now we can use our interface type here as our payment method. And like so. And then we could go about the process of creating a payment method here. And we could start using our payment object. Now, at this point, we do have obviously a lot of potential problems here. One, we don't have any validation on the types themselves, right? We're going to have business rules with all of these. Check numbers need to be some positive number. We don't take negative check numbers. We've got some rules around the date range we would accept. There's specific rules on the types of credit cards, rules on credit card number validation, the same with expiration date being in the future. A lot of rules that aren't in here. Okay. And you might say, oh, well, that's, card type, we have a set list of those. Maybe that's not the best way to model that. So we could do something like this, right? We could just give me an enum here, and we'll call that our card type. And then we could drop down here and get a little more expressive, right? We could say, okay, let's give me a Visa, MasterCard, and then we could go ahead and swap that out. And now we're starting to get a little more communication of what's valid in the types here. Okay. But let's look at modeling the similar thing here in FSharp. Okay. One of the things that is pretty interesting is the types themselves are very lightweight, and we'll see an example of that because when I get down here to the amount, yeah, the amount's decimal, okay, but um, there's rules around that. We don't want negative amounts and things like that, and there's probably some list of currencies too. We could probably do something a little bit better with currency. Maybe we could do another enum with that for currency, and then we could do some things like US, and let's say we're going to do euros, all right? And then we could tighten this up a little bit here, and we could say, okay, this isn't going to be just a string. We're going to do currency. But number one right here, without doing anything, all of these are, the primitive here, decimal, is going to be amounting to 0 as a default, and then the rest of these are just going to be null, and that's perfectly fine. We're not getting any warnings for that. Let's see what happens when we go over to FSharp and look at the type system there. So let's say that I want to model the same things in FSharp, and I could do that. So we have just the type keyword, and then we pick what we want. But we have the first thing that we can do is something really pretty interesting called discriminated unions, and we can have a single choice type. So instead of just saying that the check number is an integer, I can create a type here called check number, and it's going to be a check number type here, and then I can specify that it's specifically an int. And that might seem a little strange thing to do, but we're going to explain why that's significant in a moment here. Because in addition to this, I could do my card type here, and I could do a multiple choice type here. Now this is different than a enumeration. It's similar in a little bit, but it's different in the fact that this has some more interesting type semantics, which we'll get to in just a moment here. And then I could say, okay, well, let me see here that, and we could do other things too, like we could say that our card number is also a card number here of string. And obviously there's still more rules around what is actually valid here, but what we've done at this point is we've created a little stronger typing so that we can use these actual types in here. And I can say that the type of the card here is card type. And I can say that the card number is of this type, card number. And we're communicating more about the domain. We've gotten rid of the fact that these are primitives. When we actually create one of these a little bit later, we can put all the validation rules in a particular place, and we can be assured if we have a card info object that these are in fact valid. And that's something that is really pretty interesting. And we can continue to build our types here. Let's say that our payment amount here is also, we're going to do a payment amount of decimal. And then we can do our currency as well. Let's say that currently we take euros, US dollars. Good old IntelliSense, not as intelligent as it always is. Okay. And now we can get our payment method here. And this can be our cash, which we didn't really have any additional type info for, but we can take our check here. And we can see that it needs a check number. So when we build up these types, we can also specify not only essentially the label, but what other type is associated with it. And if we take a card, we're going to need a card info object. And then we can go build up our type for our actual payment. We can use our types here. We can say our amount is our payment amount. And our currency is, of course, our currency. And then our method is our payment method. Okay, so now ideally we've communicated a little bit more about our domain here. And if we decide that we're going to start creating some of these, let's say that we want to create our let's create our payment here. So let's let my payment be equal to, and in C# or in F# we have some interesting things here. If I just do the amount and I set it equal to something, I'm creating this particular type here. So, but I can't just say that it's, for example, 1099 as money, right? If I do that, which will come back, it'll complain about this in a minute here. Currency. Say that that's a US dollar. And then it's going to be, in addition to complaining about some white space here, it's going to be complaining about a few other things here. Okay. So one of the things that we get is that we have to initialize all of these values, right? So it's saying right here, hey, the payment method is not implemented, right? So if we just comment this out for a moment, we can see that now it's happy that I've supplied both of the required arguments here. But you can also see that, hey, this was expecting a payment amount. So this is really powerful because it communicates a lot of meaning in here, that we're not just accepting a decimal. We are accepting a payment amount. So the way to actually fix this then is we need to use the payment amount essentially as the constructor of what we want. And if we pipe it in here like so, then we can see that it's all hunky-dory, right? Because that's going to go through the constructor and then it's going to turn that decimal into payment amount. And this is all really clearly communicated in the code. And if I come back and put in my payment method, it's going to say, hey, you forgot one of these. We don't get this semantic check with all of these values in C#. So if I put in my method here and I'll just say, well, this one is good old cash here. And now we've got this assignment here, and we've got all of this nice rich semantics and meaning and all of this type with just the type system. Now granted, we don't have the code that's actually doing all of the validation, but we could certainly write that. But what we have right now at this point is that we've created this, and we know that when we have this payment object, because there's some other categories of these record types here, which is really what we're creating in FSharp. These are not the same as classes, that these are read-only, and all of these values have to be assigned. There's no nulls, and these are read-only. So if I have this, and it's already been created through whatever validation methods I've created, I know that it's valid. Now, we also get something that's really interesting, and this might be a little bigger payoff, is that now that I've created my types, I can do something with this payment method here, right? So let's say that I wanted to figure out what the payment method was. So um, I can match. So I'm going to match the my payment method with, and then I'm going to say if it's USD, just print that out here. Now we're going to get something. Oh, sorry. That's the wrong type here. So let's say that it's cash, and we're going to do cash. Now I'm going to get this green squiggly here, and it's saying this is an incomplete pattern match, because not only can I take cash, but I can also take a check or credit card. So let me account for those cases. And the other thing that it will do here is automatically take the value of the check number and shove it in there. So it automatically dereferences the match here. And the same for this. And if we look at the types here, we can see that it automatically knows that that's a check number, that this is a card info. And here's the real interesting thing. Let's say that we come over here and we now are going to do PayPal. Now I've got this match statement here telling me I'm missing the PayPal case. If we jump back over to the C# and we do something similar, let's do that. Let's say that we've got our payment amount here, and now I want to switch on my payment dot payment method. Well, actually, let me go back to um, the enumeration, because that's something that really highlights the case a little bit more. Let's say that we're going to look at our card type here. Let's say I'm going to create a credit card here as my payment. And then when we're in here, we're going to do this on card type. Now I can do my case, card type, MasterCard. And I can do my case for Visa. I can manually do this. But if I decide that I'm going to go up here and take Discover, for example, I'm not going to get any warning that my switch statement down here isn't handling that other case. If I do the same thing in C#, I am going to get that warning, right? And just to prove the case, I know I did payment method here, but let's see what happens if we match on currency. instead of method, we can see we immediately get some compiler errors here. So the two cases here are euros and dollars. So let's go with our euros here. What you'll see here is that it's complaining about the cases that shouldn't exist, right? So this is an example of, in C# we have a simple enumeration for this, but when we match here, we get more semantic meaning. If I go up here and I decide that now we're going to also take Canadian dollars, for example, when I add that to the type, anywhere I use that type and I match against that type, it's going to tell me here explicitly, hey, this is missing the value CAN, right? This is not covered by the pattern. So we would need to cover that. And that's something that I think's really pretty fantastic, that you get that compiler time check. If I do the same thing in C# and I add, another type of card here, Amex, all right, I have other cases here that it's going to fall into. It's going to fall into the default case here with these different types of cards. And we get no information from the compiler whatsoever. Same with currency enumerations. So hopefully this demonstrates here some of the power of the expressive type system that we get in FSharp, and FSharp being so lightweight that we could quickly create lots of types and communicate a lot of meaning inside of our domain here with just a small amount of code. Thank you very much.